Okay, guys, so this will be our second last lecture on structured query language. So this is the language that we use to create databases. Because like last week, we were drawing databases and designing databases, but we didn't actually create a database. Like obviously, you wouldn't open up Excel and actually create a database there. So how you do it is you use this special programming language. It's fairly straightforward, actually. It's a lot like English. I will say, please, people who are just watching the online lectures, do make an effort to attend, particularly if you can, because today it seems like it's just going to be me, Taddy, and maybe Philip after he joins. But yeah, it's not so, it feels very impersonal when you're only lecturing to so few people. So do make an effort to join. But yeah, we'll record the lecture. And I guess if you guys have any questions, just post them on the WhatsApp group. So yeah, last week we were designing databases like this. Fairly straightforward, really. It was just pictorial. There was a lot of theory and sort of logic and rules. But in general, how you would do this properly is you would program the database. I'm just going to close this, I think. There we go. Yeah, and the programming the programming language we use is SQL, structured query language. Okay, so I think we're just going to jump in. So if you're watching this on YouTube, please also open it and follow along with what I'm typing. I'll also, Taddy, for you, I'll post it in the chat as well. So you can get it working that way. So we're going to be using, it's similar to like Rex Tester, but this one is for SQL. So it's called db-fiddle.com. So db-fiddle.com. If you're watching on YouTube, I'll try to remember to put the URL in the description. So yeah. Yeah, it's a lot like Rex Tester, but for MySQL. Make sure that you select in the top left MySQL 5.7. 8.0 will work, but it might be slightly different when we get to the end. But it'll always be very similar, but just to avoid any possible problems, make sure you select 5.7. And yeah, we'll just write some SQL here. It's a good way to come to grips with how it works. I think it's formatted quite nicely as well. So yeah, let's just jump in. You'll notice, so also for those of you who have your textbooks with you and you're following along, let me just tell you where we'll be starting. So the discussions of SQL in your textbook starts at around page 155. Yeah, about 155. But they start with like using the database immediately before they've even created one, which I think you can agree probably doesn't make that much sense. So we're going to start at a different place. It's 150. Yeah. But I'm saying like the actual examples of SQL queries. You can see on like page 155, they say the select statement. That's the first one they give you. But yeah, so they start immediately using tables as if you have them. And that's because they use some sample databases that I'll show you guys in the next lecture, our last lecture that'll be. But yeah, so we're not going to do it that way. We're going to start by creating our own database. And like we'll create a fairly simple one. So yeah, let's just jump in with that. We're going to create, I think it's a good idea to perhaps create this book database because it's a nice way to illustrate all of the different things that we'll be doing. So yeah, I'm going to go ahead and create this book database. You can follow along with me and we'll see how things work. So to create a table, so that we already have a database, db-fiddle will give us a database. And to create a table in that database, because that's all the database is really, right? Interrelated data, and how we store that is in a bunch of different tables. So the first thing we want to know how to do is create a table, and you'll see that SQL has this very nice format. Oh, Bryn and okay, cool, that's great. Welcome you two. I heard you had school today, so no worries about being late or whatever. Actually, yeah, that means we can get you guys up to speed. please on your computer visit db-fiddle.com, db-fiddle.com, db-fiddle.com. It'll give you a site like this. Make sure you select MySQL 5.7. You can't. Okay, that's fine. You can just watch that there, I suppose, if that's okay. It shouldn't be that consuming, hey, because it's just your browser. It's just your browser. But no, I do understand. That's fine. You can watch along. That's chilled. And then maybe follow along like after the lecture, or if you have time when you're studying. But yeah, Bryn, can you open up db-fiddle? Make sure you select MySQL 5.7, and you'll just be following along with me. So our first task for our database is to create a table that we can work with. So let's just go ahead and do that. And the SQL expression we used to do it, I don't think it's going to require much explanation. It's create table, whatever the name of your table you want to create is. And then you just list what columns you want. And you also have to give them a type, exactly how we give them types inside C#. You also have to specify your primary key, which, if you guys recall, is the column that will uniquely identify each row. So let's go ahead and do that. We're going to create this book table, as I mentioned. We're going to leave out genre ID. So we're not going to have genre ID. We're going to have ID, title, author, and genre. Okay, so 4 columns. 4 columns. Okay, and the name of the table, just to make sure that you guys are awake, what will the name of our table be? I'm going to say create table book, precisely. Okay, cool. So we're going to say create. There's also the standard, it's just good practice. It's not necessary. Like SQL will work without this, but it's good practice, and all programmers do it, is all the SQL commands that you use, you capitalize them. Okay, so you make them fully capital. It will work in normally, but this is just good practice to follow. Okay, so we say create table and then book. Okay, create table book. Notice, so book, the first letter is capitalized, but it's just normal book, right? It's not all caps. And that's because that's the name of the table. So that's the name we're going to use to refer to it. Okay, cool. Great stuff. Okay, so now we're going to specify each of the columns that we want in the table and their types. Okay, make sure you do put a semicolon at the end there. Okay. So make sure that you do put semicolons. And yeah, so we're going to create 4 columns. Their names are going to be ID, title, author, genre. ID, title, author, genre. Now notice we also have to specify their type. So can you guys tell me, let's look at ID. From your experience, so ID, you can see it's 1, 2, 3. Those are the values that ID holds. They're integers, exactly. I didn't even have to ask the question. Nice. So we're going to say ID int. Okay, again, int there is in all caps, just because that's good practice. And there are some exceptions, which you guys will see in a bit. And there's also another aspect to this. So we can specify a few different types, and I'll discuss. Actually, do you guys remember that? I told you what a string was, like internally to the computer. What is a string? Why do we call it a string? And what is it, really? Because there's like a simple data type, and string has something to do with that more simple data type. Do you guys remember what it is that I'm trying to refer to here? Anyone? It's okay. So a string is a list of chars, or an array of chars, if you guys recall. So what is a char? It's just a single character. Like all of these are chars. Everything between these little, so that's 4 chars that I showed you there. If we link them all together, you can see that would make a string, right? So all a string is a list of characters. In C#, we decided to call that a string, but in SQL, they don't do that. In SQL, instead of saying string, we say varchar, and then however many characters we have. So varchar 255 is like a string of 255 characters maximum. So that's like the maximum number of characters you can hold. And you could specify whatever length you want, really. Okay, so that's that. The other thing that they have in SQL that will be new to us is this thing not null in all caps. So you can say not null. And all that means is that that field is not allowed to be blank. You have to fill it in. You cannot have a row in your table that does not have an ID because it says not null. Okay, so it's not allowed to be null. Okay, so that's just some new things. So then we'll say our other things are title, author, and genre. So we're going to say title, and that's going to be var char 255. You can make it caps. It's not necessary, and it's better practice to just leave this lowercase. This is the one exception, okay? Because you can see if you say varchar in caps, it looks a little bit weird. So we just say varchar in lowercase, but everything else, pretty much all the other SQL commands we'll put in caps. We're also going to have our author, and that's also going to be varchar 255, a string with a maximum of 255 characters. And then we're also going to have genre, varchar 255. Okay. Now, you guys recall, in tables, all the tables we create have a column that uniquely identifies each row. And that we call the primary key, the primary key. So it is the, so in this case, the ID uniquely identifies each book, right? So the ID is the primary key. So how we say that inside our table is we say in all caps, exactly like I've given you in the slide here. We say in all caps, primary key ID. And all that does, all saying this does, is it means whenever you try to add an actual book to the database, when you try to add an actual book to the database, it will ensure that the ID is unique. Okay, it's going to ensure that ID is unique. So you're not going to be able to give two different items in your table the same ID. Okay, that's all saying primary key ID will do. It'll make sure that every single ID in the table is unique. Like two books can have the same title, they can have the same author, they can have the same genre. The table doesn't care about that, but it'll ensure that ID is unique for every single entry. Okay, no problem, Dape. Do catch up with the lecture slides, eh? Cool. So that's actually how we create a table, but it's empty currently, right? There's nothing in our table. We've created a table that has nothing in it, which is not super useful. So the next command we're going to learn is insert. So guys, you'll notice I've boldened in the slides for when you guys are studying. I've boldened the main part of each command, like the new part of each command. So create was the first statement that we learned, the first SQL statement. The second one we're going to learn is insert. Insert into table name. Okay, and again, you can see it's just English, right? It's just English. So you guys can see, you can just read it how you would. You say insert into the name of the table that we're inserting into, insert into book, and then so I'll discuss this in a bit, but then you just give it the values that you want to insert. So we're going to say values. So insert into book values, and now you give it just a list of the values that you want to insert. So what do we want to insert into our book? The ID of our first book is going to be 1. Let's make the title of our first book okay, this is what I'm reading now with some friends, like we have a book club where we're reading The Unbearable Lightness of Being. Long title. I know you can give your books whatever title you want, but I'll also copy paste this into the Zoom chats when I'm done. So The Unbearable Lightness of Being, the author of that. So we gave ID first, then we gave the title. Now we're giving the author. It's Milan Kundera. And then the genre. This is like or it's fiction. Let's just call it fiction. Okay. And then we're going to say insert. So that would give us one book in our database. That'll give us one book in our database, which is cool at the beginning, but really we want some more books than just one, right? So let's add like 3 books to our database. So I'm going to say insert into book values. Okay. And this time we're going to insert Alice's Adventures in Wonderland, comma, Lewis. So the author of this is Lewis Carroll, and then the genre is again fiction. Okay. And then we can say insert into book. So I'm inserting one more book, values, and we're going to make this one 3. Giovanni's Room by James Baldwin. And that is also going, okay, they're currently all fiction. Let's say we're going to call Alice in Wonderland fantasy instead, just so that we can make them slightly different. And that one's called fiction. Okay, cool. Okay, let me just double check, make sure that runs. It does indeed. So I'm going to copy paste this for you guys in the chat. There it all is. So that's the code that I've got here. And so that's just going to create a table, and so it uses the create table book to create a table, and then it says insert into book values. Now notice, guys, I was specifying a value for every single column. I specified the ID, then the title, then the author, then the genre, in the order that they were created in the table. Okay, and so I didn't have to tell it which value was going where. If you wanted to do that, so if you weren't inserting all the values or you were doing things out of order, you could write here the names of the columns that you were inserting into, like ID, title, author, genre. And then let's say you wanted to insert a book without an author, you could just remove author here, and then it still knows what you're talking about, that the first item you specify after values will be ID, then title, then genre. Okay, so you can do that. Because we were specifying the value of every single column for the row, we did not have to specify the column names. Okay, so cool. That'll create our table. Nothing too bad there. Okay, make sure does what it, yeah. So the insert statement just does what it sounds like, and we specified the whole record. Okay. The last thing that I want to show you here, you can say drop table name. Okay. So the word drop, what this command would do is it drops the table from your database. So it like deletes the table from your database. The word delete does exist in SQL, but it does something different. Okay. So drop will just remove the table from the database. Okay. So drop is how we delete tables from the database. But note, it will delete the whole table. Okay. So you wouldn't even be able to insert new values into it. It'll be deleted. Okay. Cool. So that's that. That's the basics that I wanted to cover. So that's how we create a table and insert into a table. So now that we know how to do that, we can actually start working with it, right? So the computer now has some sort of internal representation of our data that's stored somewhere, and we actually want to start working with it and seeing what it can do. Okay. So this is where we get to querying. Okay, so you can notice that db-fiddle has 2 sides. On this side, we are defining what is called the schema. That's like the design and basic content, the default contents and design of our database. So that's what we defined here. And on the right here, we are going to give it the queries. Okay, so on the right, we'll be able to actually use the database. Okay, so let's jump into that. The first and most basic statement that you guys need to know is the select statement. So what statements do we know so far? Create, to create a table. Insert, to insert into a table. Drop, to drop a table. Select actually goes and selects certain columns from the table and gives them back to you. Okay. And the basic structure of this is fairly is fairly easy. So currently, this will just select every single row, and we're just going to specify what columns we want it to select from the table. Okay. So cool. Let's just try it, and then you guys will get the idea, I think. Okay. So what I'm going to do, let's say I want to view the title of all of our books. Okay. The title of every single book in the database is what I want to get. So in order to do that, I'm going to go into the right here inside. Does using tab break the code? No, it doesn't. Cool. So I'm going to do this. So again, it reads a lot like normal English. We're going to say select. Okay, so guys, I want to get the name of the books. Okay, so I used tab in my spaces and broke, then copy pasted yours and it worked. Okay, I mean, there might have been some other difference. Hey, it's easy to make a typo when you're typing this much. So cool. So I want to get the name of each book, guys. So which column am I going to select? I want to get the name of each book. So which column am I going to select? Okay, cool. Yeah, remember capital T though, hey? So it is case sensitive. So we're going to say select title from, and then the name of the database that we're fetching it from, book. Okay, and then a semicolon at the end. So select title from book. It makes a lot of sense what that command is going to go and do, right? So when I run it, so I clicked run in the top left there, you can see what it brings back. It says the unbearable lightness of being, Alice's Adventures in Wonderland, and Giovanni's Room. Okay. So it went and fetched the title of all of the books inside the book table. Not too bad, right? And what if I wanted to get the author's name? Then the column I'm going to select is author, right? So I can say select author from book. Okay, select author from book. I'm going to run that. And you see it goes ahead and it gets the author. Okay, cool. So we know how to get specific columns. You just say select and the name of the column you want to get. If you want to select more than one column, like let's say we want to get the title and the author. Yeah, you're right, Dappe, it does make sense. And if we want to get the title and the author, you can just separate them by commas. So I can say select title, comma, author. Okay, select title, comma, author from book. And if I run that, you can see it'll go ahead and it fetches the title and it fetches the author. Okay, so this is working pretty well. But what if you want to fetch the entire table? One way you could do it is you could say select ID, comma title, comma author, comma genre, right? That's every single column in our table. We only have 4 columns, so that's all of the columns in our table. You can imagine there could sometimes be a case where you're storing a lot of data, right? Like a lot of columns in a single table. And so there's a shorter way of doing this, okay? If you just want to select every single column, you can, instead of typing out the column names for all of them, you can use the asterisk, okay? Asterisk, so like star. So if you say select asterisk or select star from book, then that is the same as saying select all from book, basically. Select all the columns from book. So you can see I'm going to run this now. And you can see it now fetches ID, title, author, and genre. Okay, so that's what star does. It just goes ahead and fetches every single column. Okay. Not too bad, right? So that's the select statement for now. Fairly simple. You can see that it selects every single row, which, again, you can imagine if we have 100,000 rows, selecting all of them is not quite useful, but we'll see how to exclude certain rows later. But yeah, for now, that's a fairly easy statement to remember. Okay, cool. So that's select. There's another statements as well, though. So there's update. And as you probably can imagine, updates will update the values in your database. So you can say update, the name of the table you want to update, and then set, and then whatever you want to set column 1's value to, column 2's value to, comma, column 3's value, etc. You can go through. Okay, so let's just go ahead and try out this command and yeah, see how it works. Bryn, are you here, by the way? You're quiet. I guess we are typing quite a lot, so that makes sense in a way. Okay, so I'm going to say update book. Okay, and we're going to say set, and then we say the column name that we want to change and the value that we want to change it to. So let's say we want to update title to unknown title or something like that. Okay, so we're going to say set title equals unknown title. Unknown title. Okay, and then a semicolon at the end. Don't forget the semicolons. Okay, now that will update the database or update the table book, but we want to also, obviously, we need to display the results. So after the updates, I'm also going to go ahead and select. So I'm going to say select star from book, okay, because that'll actually display the results, right? The update will update the table, but it won't display anything. So we have to select as well to display what the new table will look like. So I'm going to run that. And you can see what that went and did. It changed all of the titles to unknown title. Okay. So again, the problem, just like what select was doing, you can see that this is working on every single row of the table, which hopefully you can see is not super useful, right? Like usually you want to work on a specific row or like a set of rows. So yeah, let's think about this for a little bit. But yeah, so we have update book, set, and then the column you want to change and whatever you want to change it to. And again, just like with the select statements at the beginning where you can specify the different columns you want, you can do that here too. You can say set title equals unknown title, comma, author equals unknown author if we want to update both of them. Okay, we can say unknown author. Okay, like that. And you can see if I run that, you can see it now changed title to unknown title and author to unknown author. Okay, not too bad. Again, it's working on every single row, which is a bit weird, but we'll fix that now. Okay, cool. So that's the update statement. So this statement, as it stands, as we've seen now, will update every single row in the table. And you saw that the select statement went and selected every single row in the table. And I think you guys can agree that's not super useful. Usually we want specific rows. We want to figure out what we want, right? You don't want to work on the whole table of like 100,000 items at once. So what we're going to do is learn how to exclude certain rows. And it's pretty easy to do. It's like a very standard format. The word we use is where. Where. Okay, so you can see the statements we were using before were like that. Select whatever columns from whatever table, update the table and set the column to a value, right? But what we can do is we can add the word where at the end of the statements, and then we can add a condition, sort of like how the if statement conditions look, if you guys remember from C#. So you can say, I want to select the column from the table where ID equals 1, or where genre equals fiction, or something like that. Okay, we can do lots of different things. Cool. But let's go ahead and try that now. So let's go and try use the where condition. Okay. So we're going to start by just using a basic select statement. So I'm going to say select star from book, and that's going to go ahead and give us our original table. Okay, so we've got the normal titles, the normal authors. Okay, select star from book. But let's say I actually want to get Alice's Adventures in Wonderland. I just want to fetch that book, Alice's Adventures in Wonderland. I don't care about the other two. Okay, so what I'm going to do, I'm going to say select star. So that's going to go ahead and get every single That's going to get every single book. So I mean, every single row, sorry. I mean, column. Okay, think. So select star. The star means all of the columns, right? From book, okay? Currently, this would get every single row, but I want to exclude certain rows. So I'm going to say where. So select star from book, where, and the condition I'm going to put is where ID equals 1, and only one equals sign, hey? So ID equals 1. So it's slightly different to C sharp, you guys can see. In C sharp, we would say equals equals, right? To make sure that they're the same. But in this case, equals will work, okay? So select star from book where ID equals 1, and I'm going to run that. Oh, sorry, but we wanted Alice's Adventures in Wonderland. So it's actually ID equals 2, sorry. So where ID equals 2, and you can see 2, Alice's Adventures in Wonderland, Lewis Carroll, fantasy. Okay. So that just fetched that book. Cool. So we could filter by other ones as well. So if I just get where ID equals 3 and I run that, you can see that that will give me Giovanni's Room by James Baldwin. Okay. And you can see you can start doing some interesting stuff here. So let's see. Let's say I want to fetch the authors' names of all the names of all of the authors who have written a book in which the genre is fiction. Okay. I want to get all the names of all of the authors in which the genre is fiction. So you guys are going to help me write the statements and then we'll take a little break. Okay. So let's say select. So that'll go and fetch the rows. Okay. So what column am I going to select, guys? So I want the names of all of the authors who have written a book whose genre is fiction. That's the final goal. But which column will I start by selecting? Oh, wow. Okay, so Tari just wrote the entire statement. And that's, so almost, I think. So that's the statement that Tari posted in the chat. So this is almost there, almost there. The only issue is this fiction on the right here needs to be in quotes. Yeah, okay, cool. You also got, okay. So you also saw where it got wrong in the chat. It went wrong in the chat. But yeah, that's cool. And you can see that gives us Milan Kundera and James Baldwin. Okay. So yeah, 100%. I think you guys get the idea of this. So yeah, that's cool. That's the where statements. There are a lot of other possible conditions, which we'll see on the next slide. But yeah, we can leave that there for now. Okay, let me show you one more thing before we take a break because it's very similar. You can also say delete from table name where condition. Okay, so for example, you could, and again, it just makes sense. Like if you understand select and update, you'll understand delete. We can say, so let's say we want to delete Alice's Adventures in Wonderland from the database, or we want to delete all fiction books from the database, okay? We want to delete all fiction books from our table. So we're going to say delete from book where genre equals fantasy. That'll delete all fantasy books, all of the fantasy books from our table. Okay, and just to show you that it does, I'm going to say select star from book. Okay, just to get the output after that query runs. So there we go. I'm going to run that. And you can see we've now only got The Unbearable Lightness of Being and Giovanni's Room because they're both fiction. Alice's Adventures in Wonderland was fantasy. And so we deleted it. Okay, so the where statement also works with delete. So now you can see in order to delete a table, we say drop table name. Okay, in order to delete a particular row, we say delete from book. But if you just said delete from book, if you just said that without the where, that will delete every single row in your table. It won't delete the table, but it will delete every row in the table. And So if we add the where, then we can target specific rows. Okay, so that's that. Cool. So those are those three basic statements. We'll get on to some of the other conditions that we can have when we come back from a break. Shall we break until like 5 to 4 around? Yeah, we'll get started then again. You guys can go and get some water and chill a bit. Cool. Nicely done, Sadi. I'm impressed that you just wrote the query. I wasn't expecting that, but I guess it's a good sign. Oh, that's a pity, Dape. So when this is over, huh? Okay, cool. Sure. Will do. Ooh, I'm just gonna stop sharing for a bit. Sure. Far away. What is forensics? Wow, that is off topic. A formal definition is tough. It's like studying a crime scene. Studying a crime scene with like various, like doing testing for genetics and fingerprints. Yeah, CSI stuff. Exactly. I would search for a formal definition, but I'd probably just forget it. But I mean, there are forensics in other fields as well. Like you could actually get like cybersecurity forensics even. which would like study how someone broke into a system or something like that. So there are people who do that sort of thing. Yeah, yeah. Well, I would think almost always crime related. There might be a context where you use the word forensics where it's not like a crime. But yeah, no, generally it would definitely be crime related. Let's get that formal definition since we have 2 minutes anyway. Forensics. Okay, yeah, so very crime related. Forensics are the scientific methods used to solve a crime. Forensic investigation. Huh. Scientific methods to solve crime. Ford Motor Company. I thought that would look weird. Why was I searching Ford? I think that was a suggestion though, actually. I don't know, it's difficult to tell now. Been using Google for so long that I can't tell between my Google history and Google's recommendations. Unbearable lightness of being. Oh, okay. Yeah, that sounds right. I don't think I've ever searched for Ford though. At least I don't know why I would. Oh, wait, I think I was doing, yeah, I heard an interesting stat that Tesla in combined value is now larger than the next 3 largest car companies in the US. So like Ford, General Motors, and is it Chrysler or something? I don't know. I don't even know what the other one is. Yeah, it almost seems a little bit unbelievable, actually. Like, I wonder how long that can stay true, you know? But anyway, let's focus. So you know why Tesla will never come to SA? Load shedding? Yeah, seems correct. I can believe that. Cool. So let's focus. So these are all of the things we can use to define conditions. Yeah, exactly. No one would be able to charge their electric cars. But yeah, so these are all of the things that we can use to define conditions with the where statements. Okay, so the first ones you should be pretty familiar with. I'll show you a couple of them. So we've already seen equals. So equals is how you can create a condition for equal to. So like ID equals 1 or genre equals fiction or fantasy or whatever. And the other ones are kind of similar to that. So we've got greater than, less than. They mean the same as they do in C#. Greater than or equal to, less than or equal to. Those also mean the same as they do in C#. This one here is a little bit different. So you can see it's like both the less than sign and the greater than sign. What this means is not equal to. So not equal to. Everything that is not equal to the thing that you give it, okay? So let's play around with these, but basically this last one means the same as exclamation point equals does in C#. So let's play around with these a little bit and see what we can do, okay? So cool. We'll start with the super basic conditions. I'm not going to do equals to again because I hope you guys have probably gotten equals to by now. So let's try the others. So we're going to say select star from book where. Okay. You know what? I think we should add some more books. I had this problem last time too, where there's not really enough books to demonstrate conditions. So I'm quickly just going to add 2 more books. Let's do 4. Capitalist Realism by Mark Fisher. We'll add. Okay. Getting pretty political. Well, I guess it's philosophical, isn't it? It's more philosophical. Philosophical. Okay. I think that's how you spell philosophical. Looks right. And then we'll add, what else should we add? Anyone have a good book that they want added? Let's do The Trial. The Trial by Franz Kafka. And this we will call Absurdist. Okay, cool. So let me just share these with you guys. So I'm just sharing the full list of 5 books that I added. The create statement is not there. Okay? The create statement is not there. Those are just the 5 books that I have in my database now. Okay, cool. So that gives us a little bit more to work with. So we've now got 5 books. Ooh, okay, hold on. I must reshare it with you, I guess. Oh, no, it's just because I left out the... Cool. Never mind. So yeah, that'll work. Those are the 5 books that I have in my database. If you're watching on YouTube, you can take the time to type them out as well, I guess. Cool. So there's the 5 books that we've got. Select star from book. You can see we've got all our books there. Great stuff. So now we can actually use the conditions in an interesting way. So cool. I think let's start with the greater than and less than, just to show you that they really do mean the same things. So let's say we want to get the first 3 books that we added to our database. So the first 3 books that we wanted to add to our database. We can say select star from book where greater than 4. So that would give the last 2 books that we added, right? Or just 5 actually. So if we said where ID greater than 4, that will only give us book 5, right? Because the only book that has an ID greater than 4 is book 5. So maybe, well, flip it around, Dape. Try flipping it around. So what will I type? What am I going to type? Where ID, okay, yeah, well, in a way, but we would rather, so we're not going to put ID on the right. So we'll say like that. Okay, so we're just going to flip the arrow. But yeah, right idea. We need to ask for things that are less than 4, right? So there we go. Now we get the first 3 books. The other way we could do it, right? Because there's another sign. It's both ways are equally correct. But we could also say less than or equal to 3, right? Less than or equal to 3 in our case is the same as less than 4, right? Because we go 1, 2, 3, 4. There's nothing between 3 and 4. So you can see that also gives me the first 3 books. Cool. So that's greater than, less than or equal to, and greater than or equal to. They mean the same things they do in C#. The one thing that's a little different is the not equal to. So we say less than sign, greater than sign. That means that all the books that are not equal to 3. Okay, so all the books that do not have an ID of 3. So that'll be books 1, 2, 4, and 5. And you can see when I run this, we get books 1, 2, 4, and 5. Okay. We could also do this with genre, right? So can someone tell me what condition will I write if I want every book whose genre is not fiction? Every book whose genre is not fiction. What condition will I write? Yeah, that'll be the condition, but what will be on the left and right of it, Taddy? You're getting out easily. I mean, I guess it makes sense if you... so genre is not fiction. It is as intuitive as you would think it would be. It's basically the same as using an equal sign. It's just the sign changed. Where genre, exactly. So we'll say where genre 24. Oh, no, Dape, that's okay. Okay, no. Okay, now I see what you're getting at. That's, in a way, that's clever. But yeah, so that's not how we do or. I'll show you that in a bit. But yeah, okay, now I see where you're coming from, because books 2 and 4 are fiction. So no, I get you. That's, yeah. But yeah, so how we would do it in this case is like this. But in a way, I like that creative thinking, actually. But I'll show you how we would do something more like that now. Not ID, not fiction. Sorry, genre not equal to fiction. Okay, I made a little mistake there. Genre not equal to fiction. And you can see that gives me 2, 4, and 5. Okay. Oh wait, it's 1 and 3 that are fiction. But I get where you were coming from. I get where you're coming from. It's 1 and 3 that were not fiction. Okay. Or 1 and 3 that are fiction. Okay. But yeah, we'll do it. We'll do it now. No. So it's not that simple. Or is a little bit complicated, actually. Or is a little bit complicated. You could, in a way, do that. Like, you could say something like ID. I'm not sure. I wouldn't do it this way, but I'll show it to you just out of interest, where ID is not equal to 1 and ID is not equal to 3. That could probably work. Yeah. Okay, so that works. So you can say and, but there's a better way to do this. There's a better way to do this. And you can see the word and, it just makes sense there, right? So ID is not equal to 1 and ID is not equal to 3. So that excludes the books with ID 1 and 3. But there's an even nicer way to do this. So there is an or, but the or kind of doesn't work for this case. You don't really use this or in this context. You can see or just makes it always true. Okay, so you don't use or in this context, but you can use and. That's why I wouldn't use this, because like the and or, they don't really make particularly the or doesn't really make sense in, well, I guess in that context it did make sense because it did work there. But let's try ID equals 1 or ID equals 3. Let's try that, run. Okay, so there it does work. So yeah, you can use and or, but just be careful about it. There's a better way to do or. Okay, there's a better way. So yeah, let's continue. Cool. So those are like the not equals to, less than, greater than, less than or equals to, greater than or equals to, okay? So here we said ID equals 1 or ID equals 3, and that gave us 1 and 3. And yeah, cool, makes sense. But yeah, so there are these other words that SQL provides, okay? So they are between, like, in, and not, okay? Between, like, in, and not. So, yeah. Okay, so between is a fairly obvious one. So let's start with between. So let's say we want all of the books whose IDs are between 2 and 4. Okay, literally what we'll say, and it's literally just how you say it in English. It's basically exactly what I just said. We would say select star from book where ID between 2 and 4. Okay, where ID between 2 and 4. And that'll give us all the books who have IDs between 2 and 4. No. So that it's inclusive, Dape. So it includes the ones on each end. But yeah, good question. So it's inclusive. So you'll see this will give us 2, 3, and 4. Okay, so you see. So yeah, exactly, inclusive. So that's cool. So where ID between 2 and 4, it just reads like English, and you can give it any range you want. If you wanted, let's say you wanted the range that is outside of 2 and 4. So I will forever not use commas. yeah, it does make sense. The commas are dangerous. You basically only use them when specifying like in the create table and like separating between the values and that kind of stuff. Don't really use them here. Okay, not after the where. Okay, so we say select star from book where ID between 2 and 4. And the other thing is you can say the word not also exists. So we can say where ID not between 2 and 4. I'm not sure if we should put the not before, actually. Yeah. Okay, cool. So it says, so we say where ID not between 2 and 4, and you can see it now gives me 1 and 5. Okay. So it's quite clever, right? So you can say not to like negate it, and you can negate anything you want. Okay, so you can say, yeah, it's very self-explanatory. So I'm just showing you all of the different things you can do. So you could also say like where not ID equals 3, where not ID equals 3. So can you guys tell me what that would give me if I say where not ID equals 3? Which ones will that give me? Yeah, exactly. So you can see when I run it, it gives us 1, 2, 4, and 5. So you can negate any condition you want by just putting not in front of it. Okay. Yeah. Cool. So that makes sense. Okay. So we'll come back to like. So convinced he's a bot. So we'll come back to like in a little bit. Let's talk about in first. So we're going to talk about in. And Dape, what you brought up, I think in is the better way to do this. Okay. So if you want to say like, let's say we want to pick all of the books who are either fantasy or absurdist. Okay, so we have one book that is absurdist and one book that is fantasy. Okay, Alice's Adventures in Wonderland is fantasy, and The Trial by Franz Kafka is absurdist. Okay, so we're going to say all the books where the genre is either of those two things. So you guys could see, we could say where genre equals fantasy or genre equals absurdist. That would be fine. But the better way to do it, that just makes more sense because you don't have to use these weird conditionals like or. You can just say where genre in and then give it some brackets, and you literally just specify a list of possibilities. Okay, so the list of possibilities we're looking for are fantasy and absurdist. Okay, absurdist, where genre is in that list. And you can see when I run this, it gives us, oh, did I spell absurdist wrong? Sorry, I spelled absurdist wrong. There we go. And you see it gives us Alice's Adventures in Wonderland and The Trial. Okay, so that's the better way to say or, because you don't have to use the word or and think about like the actual logic. Because remember that like or means either of them can be true. And you can imagine if you're chaining a whole bunch of ors together, like if we wanted all the fantasies, absurdists, and a bunch of other things, it would be like, it would get a bit much. So saying in is generally better. Like if they ask you how to pick this or that, you say in and you give it the list of the things that you want. Okay. Yeah, from typing in chat. Cool. Okay, one more. Bryn sends a WhatsApp message. Oh, okay. Sorry, sir, I have to go. Okay. Cool. We're making good progress though, so YouTube video should be good. So, unlucky Daphne. So next, we want to learn about this one like. Like is a little bit weird. Okay, like is a little bit weird, I'm going to say. So like allows you to specify a pattern. Okay, I was... I mean, it is a web browser. So like your computer would have to be particularly bad in order to not be able to run a web browser. But okay, let's focus because we're making good progress. So let's just cover like. So like allows you to define a pattern. So you can say where it's like this, and you can specify a pattern. There's a number of ways we can specify patterns though. So I'm going to show you some basic ones, like the ones they can ask you. And basically we use what are called, they'd usually be called, I guess, radicals. But the point is they're like symbols that represent a certain idea. So I'll do it briefly. So let me start with an easy one. Okay. And so let's say we want to select all the books who have, let me pick one that's a little bit interesting at least. Unfortunately, none of our authors have first names that start like they have the same initials. Okay, this is a good one. Okay, so let's say we want to select all the books that have a title starting with T. Okay, all the books with a title starting with T. All right, so that's what we're going to do. So how we would do this is we would use the word like. So we can say select star from book where title like, and then in these quotation marks, we can specify a pattern. There's two important symbols that you guys must know about patterns. It is underscore, okay? In the underscore means any single character. So any single character. The other one you must know is the percentage sign. That means any string of any length. Okay? Cool. So that might not make sense yet, but so we're looking for all of the books whose title starts with T. So I'm going to say where, title, like, and then I'm going to put the letter T. Okay, so T, and then I'm going to put a percentage sign. Okay, so what is this pattern saying? It is saying the first part of the title is the letter T, and the second part is anything else. I don't care what comes after the T, as long as the first thing is T. Okay. Yeah, exactly. It will be 1 and 5. So we're going to say run. And you can see it gives us the trial and the unbearable lightness of being. Okay, so that's quite a simple example. You can see that. So let's see which titles contain T at all. So capitalist realism contains a T. The only title that doesn't contain a T is Giovanni's Room. So let's say I want any book that contains a T anywhere in the title. Okay, so in order to do that, I can say, okay, the pattern is that there can be, let me start from the beginning. So it can be anything with a T in the middle, followed by anything. Okay, so percentage, so that's anything of any length with a T followed by anything. And you can see the books that match that pattern are all of the books except Giovanni's Room. Okay, because Giovanni's Room does not contain a T anywhere in the title. Okay. And you can see that we could start doing pretty complicated stuff. So let's say, so that's the percentage sign. It means anything. Okay, so anything of any length. We can also do even more interesting patterns. So let's say I want all of the authors who the second letter of their first name is an A. Okay, so that's James Baldwin because the second letter is an A, and Mark Fisher because the second letter is an A. Okay, so how I would define this pattern, I would say, okay, the first letter can be any character. Yeah, exactly. %T% inside quotation marks though, Taddy. Okay, so that means anything followed by the letter T followed by anything. Okay, that's what that pattern defines. Oh, you might be wondering because it's lowercase, because the trial technically doesn't have a lowercase t. Oh, okay. But also the case doesn't matter, Taddy. Okay, cool. Yeah, the case doesn't matter. So lowercase t, uppercase T doesn't matter. Okay, cool. But now what we're looking for is any author who the second letter of their first name is A. So how we would define that is we can say, okay, the first letter can be anything, but only the first letter. So we're not going to say % because that means anything of any length. That would say as long as there's an A somewhere, right? What we want is if the second letter is an A, so we just don't care about the first letter. So we say underscore. So you can replace the underscore with any character you like. The second letter must be an A, and then we can have anything you like of any length. So we say %. Okay, so do you understand what that means? That means any character can replace but only one character. Okay, so the first letter of their first name can be any single character. Then the letter A, and then anything you want of any length. Okay, and so when I run this, you can see that we get authors who, let me think. Oh, where title. Sorry, I said where title. We want to say where author like. Sorry about that. So not where title, where author like. And you can see we get James Baldwin because the second letter is an A, and Mark Fisher because the second letter is an A. Okay. So to do the third character to be A would you use exactly, Tudley? So if we wanted to get any author whose third letter is, I don't think we have an author whose Franz Kafka, exactly. So yeah, if we want just Franz Kafka because the third letter in his name is A, we can say underscore underscore. So that'll mean any two characters you like, then an A, and then anything you like. And so you see when we run this, we'll get Franz Kafka. Okay. Pretty cool. And yeah, we can do, yeah. So once you know those radicals, it just makes sense. Okay, so underscore any character, %, any sequence of characters. And then you can like design little patterns however you want. Okay. Like, yeah, you could say the first letter must be an L and the third letter must be a W. You could say L underscore W %. So that means the first letter of their name must be an L. The second letter can be whatever they want. And this will obviously give us Lewis Carroll. Okay. So yeah, you can get pretty crazy with these patterns, but that's what like does. Cool. There is one more thing that I want to cover with you guys today, but we won't finish this lecture totally, but I kind of expected that. You can see, so the definition of database, if you guys recall to the beginning of last week's lecture, the definition of database was a collection of interrelated data. Okay, so currently we have a single table, but the whole point of the database is to have multiple tables that are related. Okay, so yeah, what we want to do is just quickly create that little relation. All right, we want to create a relation. And how you create a relation, it's the same create table statements, except you add what is called a foreign key. Okay, so I think it's best to just learn this by practice. Okay, so let's just go ahead and do it. What we're going to do is we're going to separate. You can see we're repeating genre a lot, right? We're saying, so like fiction is repeated, right? Which is not ideal. You don't want redundancies, right? You don't want to have to repeat the same piece of data in multiple rows, like especially when it's a full varchar. You would rather store that in another table and reference fiction. Okay, so what we're going to do, we're going to just create another table called genre, and that'll be easy. So it'll be exactly how we created table book here. We're going to say create table genre. Cool. Our genre needs an ID, right? Just like all of our other pieces of data need IDs. So we're going to say ID int not null. And you guys know what that means. So it's an ID, it's an integer, and that's what we're going to uniquely identify each genre with. Our genres also need a name. And yeah, not null means it can't be empty, precisely. So our genres need a name as well. So we're going to say name varchar 255. Okay, cool. And you know what? We can say this can't be null either. If you're going to add a genre to the table, you have to give it a name. You can't just have a genre without a name, because that wouldn't even make sense. So yeah, because that's all a genre is its name. So we're going to say that's also not null. Okay. We're also then going to say primary key is ID. Okay, that's the primary key of our genre table. Okay, so there we go. We've created the genre table. But now what we want to do is we want to tell book that the items in book reference the genre table to get their genres. So basically, instead of saying genre over here, the name of the genre is defined there. So instead of saying genre over here, we're going to call this genre ID inside book. Okay, so it's going to be another ID, and we're going to turn it into an int. Okay. Then we need to tell book that genre ID is referencing ID inside the genre table. Okay. So, and you can picture it. So whatever genre ID you specify here will specify a certain row of the genre table, if that makes sense. So how we say this, what we call this, we call genre ID a foreign key. A foreign key, because you can see, so ID is the primary key of the genre table because it uniquely identifies each row. Genre ID references ID. So it's like a foreign key. It's a primary key from another table, okay, a foreign key. So it's quite a clever name. And how we say that in SQL is, as you'd expect, exactly how we say it in English. It's foreign key, the name of the column that's holding the foreign key, references, and then whatever, you have to specify the name of the table that it comes from and the name of the column in that table that it is referencing. Okay. Why are you saying yesh or yeesh? What's up? So we say, yeah, cool. So we say foreign key. Okay, so foreign key, the name of our foreign key is genre ID, okay? And it references genre, so that's the name of the table, okay? So it references genre ID, okay? And that's the name of the column in the genre ID table, okay? So genre, that's the name of the table that we're referencing. ID is the name of the column in the table we're referencing. Okay, so it makes sense. Foreign key genre ID references genre ID. Okay. So do understand. So this is the name of the column over here is genre ID. And this is the name of the table and the column in that table. Okay, cool. So that's how you create a relation inside SQL. And now we just have to change our data a little bit. Okay, so I need to say insert into genre values, and we need to create like a couple of genres. So 5 of them, well, not 5 of them because some of them will be the same. So our first genre is going to be fiction. Okay. And I'm just going to copy paste this just to speed this up a little bit. I think we have 4 genres total. Our second one will be fantasy. Its ID must be 2. Okay. Our third genre, so that would be fiction. So then our third genre will be philosophical, if I'm even spelling that correctly. And our fourth genre is going to be absurdist. Okay. So the end of making a table, you should write the primary key and the foreign keys. Yeah, exactly. Yeah, so you specify, and all the foreign key is going to do, it's like quite a simple rule that this will enforce. All it's going to say is that if you specify a genre ID for a book, it's going to check that that genre ID exists in the other table. If it doesn't exist, it won't let you reference it. Okay, so it's just a rule. Okay, like in a way you could do it without this. It's just that it'll now enforce that when you insert data, it must be consistent. Okay, so it's important to state this. Exactly like with primary key. Like you could technically, it will automatically do it, but you could technically not specify. And then when you try to insert, it will like allow you to insert multiple values of the same value, like some database managers. So yeah, but it's best practice, just always specify primary key and foreign keys at the end. Yeah. Cool. And so now instead of writing the whole genre here, instead of fiction, I'll just say 1, right? Because that's the idea of the fiction genre. Instead of fantasy, I'm just going to say 2. Instead of fiction over here, we're just going to say 1. Instead of philosophical over here, we're just going to say 3. And instead of absurdist, we're just going to say 4. Okay. Cool. So that's gone ahead and created our table. You know what? I'm going to copy all of this into the chat. And yeah, so now I just want to show you guys one more command, because this will also change slightly how we use the database. And this, we're saving the best for last, because this is by far the most difficult SQL command. Like all the ones we've seen so far, I think you guys can agree, they're fairly intuitive. A lot how we just say it, right? It's very similar to just standard English. But now how we actually work with multiple tables is a little confusing, because it's not really, I'm overplaying it. It's the reason I am is because when I was taught this in high school, I did not understand. I really did not understand what was going on with this. Hopefully I explain it a little bit better than it was explained to me. But yeah, cool. Anyway, so let's try it out. So we're going to say so select star from book, and I'm going to say comma genre. Okay. So we're going to select everything from book and genre. Okay. You might think that would work, right? If you look at how we select columns, you might expect this to work. And when I run it, you can see that it doesn't work. Okay. It doesn't work. You see what it gives us? It gives us this crazy long table, right? Unbearable lightness of being repeats 4 times, once for each genre. And then Alice's Adventures in Wonderland repeats 4 times, once for each genre. Giovanni's Room repeats 4 times, once for each genre. Capitalist Realism repeats 4 times, once for each genre. And The Trial also repeats 4 times, once for each genre. Okay, so that's not ideal. I think you can agree. That's not what we were expecting when we were relating these two tables to each other, right? And the issue is that the SQL query, the SQL query over here, doesn't know how to relate the tables. Just because you specified the foreign key over here, that does not as I said, this is just enforcing that little rule that it has to exist before you can reference it. But you can see that it doesn't enforce it in the query. It doesn't know how you expect to relate these two tables. And so you have to tell it. And the way we tell it is called inner join. Okay, inner join. So we essentially join the two tables and we tell it where we're joining the two tables. Okay, so again, it looks long, but hopefully you'll bear with me. I'll talk through each part of the command. That's the full command and how we would join two tables together. And yeah, so it does seem scary, but it's actually not too bad, like once you get a hang of it. And yeah, this is the last thing we'll be covering today. So we want to join book and genre, okay? So how we're gonna do that, we're gonna say select star from book, okay? So that just selects everything in the book table, okay? That's okay, that's okay. So you can see it just gives me everything in the book table. The only thing that's changed is that the genre ID is the genre ID, okay? But instead of having the genre ID here, I want the actual genre's name, okay? I wanna join the two tables, okay? How I do that is I say, okay, inner join genre. Okay. And I'm sure you guys can agree if it was just that, if that now just joins those two tables together on the foreign key, that would be pretty cool, right? That would be pretty obvious. But the thing is, the SQL query doesn't know what column to join the tables on. It doesn't know which columns to like link together. Like it doesn't know that genre ID must be linked to the ID of genre, okay? Just because we specified the foreign key, it still doesn't know. SQL just doesn't work that way. So you have to specify here. And so that makes the query a little bit longer. So you have to say, select star from book, join it with genre, and you have to tell it what column to join on. And how you do that is you say on, and now you just have to give it the two columns that are supposed to be equal. And what we want is for book.id to be equal to, book.genre ID. I almost messed up there. So we want book.genre ID to be equal to genre ID. Okay. Why? Because it's getting tough, or because you have to go? Cool. And you see there it joins the tables into one. Okay. And it works fairly sensibly, right? You can see that all of the genres are there in their correct place. Okay. Okay, cool. Cheers, Dape. Yeah, we're basically done now anyway. That was the last command. But now what I want you guys to understand, for those of you still watching on the lecture, yeah, okay, cool. I'm glad. But what I want you to get is this whole thing now, this entire line. So book, inner join, genre on book.genre ID equals genre ID is the same as a normal table. Okay, it's the same as a normal table. So you can still just say select title from this. Okay, it works exactly like a normal table. Okay, so you can see that just gives me the title. You can select genre.name, and you can see that'll just give me the different genre names. But you see it gives me 5 of them because the tables have been joined. Okay, so it says fiction, fantasy, philosophical, absurdist, because it's treating this entire thing, book, inner join, on book genre ID equals genre.id. It treats that entire thing as one table. And so you can add a where statement here exactly like you usually can. It works exactly like a normal table. You just, as long as 2 columns don't have the same name, if there's 2 columns with the same name, you need to specify, like you need to say genre dot whatever column. Don't just say the name of the column because it won't know which table you're referring to the column from. Okay, so that's the only difference. But it is just a normal table. You can treat that whole statement there, book, inner join, genre on, that whole thing, you can treat as if it was just a table that was strictly defined in this way, like one table. Okay. And yeah, that's it for today, guys. That's relations. Oh, so the moment you join both tables, it becomes one, being able to use where and all the, yeah, exactly. So nothing changes about everything else we've been doing. It just treats this like this entire big table down here. It's as if that was literally the table. Like if this exact table was defined as like book genre, for example, like the book genre table, and we inserted everything into it, it would be exactly like this. Yeah, exactly. Cool. Hope that makes sense. And yeah, great. That's that. Yeah. And next week is our final lecture. For those of you watching on YouTube, please make an effort to attend. Okay. But yeah,